Hello. In this video, we'll walk you through a small example of finding a vulnerability in a program through CPG exploration in Flowfinder. So let's get started. We'll start in the Flowfinder UI already loaded with an example program. We need to have an entry point. So let's go ahead and select a function that we know we need, this receive function. And we want to see where this function is actually called from. So let's right-click on it and show the call sites. And now we can see there's a handle loop function with an instruction to call the receive function. Okay. Now we know that network input enters the program in this call to receive and handle loop. But what happens after that? So let's look at the call instruction again, and let's show control flow from this node. So this gives a kind of fairly large graph. Let's try and give ourselves a little more space to look at it, recenter it. Still pretty large. So let's actually go ahead and collapse all the lower level nodes. Now we have a receive function and a handle loop. But if we click into the handle loop, it'll expand it out, leaving the child nodes still collapsed so we can get a better view. From here we can start to get a picture of the flow. Now you should be able to convince yourself that the receive function is inside of a loop, so the control flow graph is following the call exactly with the CFG of the handle loop function, which consists entirely of this loop. But let's go ahead and hide this and try something else. So we'll find the card for that control flow graph and we'll disable it. That CFG was a little overwhelming, kind of with the suboptimal signal to noise ratio. So let's try just looking at the places where the data from the receive call gets used. So let's go back, open this up again. And let's look at this and look at the data flow from this node. The graph seems a little sparse. First of all the targets are in the handle loop, but surely user-provided data flows to other functions. The problem that we really want to track down is the flow of data originating outside the program. The mechanism Mate uses for this purpose is called an input signature. There are also corresponding output signatures, which represent the effect of the program on the external world, things such as printing messages, creating files, etc. So let's go ahead back to our call to the receive function. And let's show data flow and I/O signatures. Now, we can see these input signatures for the call. Let's take this one and let's show the data flow from this node. Now, we should have a much more interesting graph of the data flow. In fact, if we were to zoom in here, let's make a little more space for ourselves so we can see things a little more clearly. And let's collapse a few things. We've got an fprint function over here that we can probably collapse, and the string len, and the command write. And for the time being, we can actually just probably collapse the handle loop. But now, this is a much more interesting graph. Can you see the vulnerability? I'll give you a hint. It's a path traversal. The problem is that the user input from this call to receive flows to the path argument for this fopen. And the key here is that there's no sanitization. So this means the user can input a key that traverses the file system to some sensitive information and read the contents of that path. So let's do a little further digging. So let's take this output signature from the fopen and let's look at the call sites for it. Now, you should be able to see that this vulnerable occurs in the command read function. Congratulations, we found the vulnerability. Now, if you'd like to understand how the data flows from the receive to the fopen in more detail, let's look at the memory. Now, in order to do that, we need to show the memories. They're hidden, the memory nodes. They're hidden by default because often a graph can contain a very large number of memory nodes, creating a lot of noise that's difficult to see. So let's enable our memory nodes. If we come back in here, we can now see this green circular node that's in between our input signature and our fopen. And this indicates the data flows through the stack allocation that was allocated inside of the handle loop. Now, let's look a little bit deeper at this allocation node. Let's find the allocation site for this. Okay, and you can see that here, inside the handle loop, the alloc instruction, which was allocating this buffer. This is corresponding to the local variable at the C level. All right, now let's come back to our call instruction. Let's look at the operands for this instruction. And we see we have this get element pointer. And so let's show the operands for this. From here, you should now be able to see that this buffer is passed as the second argument of the receive. Pretty nice, huh?